well, next word problem. Well, our problem, word problem. So if you look at this, I don't know who created this, but anyway, use your creativity, fill in the blank here. I will do this. Hopefully you are enjoying the math. Alright, so if you look at this, the question talks about doubling period. So I hope you know what we are talking about here. If you look at your formula sheet, it would be this. Growth or decay formula. If it is like half-life, B is 1/2. If it's doubling, that means B would be 2. If it's tripling, B would be 3. So Y goes to A times B raised to the power of T over P. So let's do this. First thing, Y equals to A times B. This is the last thing we did for the exponential function for the first half of this unit here. Okay, raised to the power of T over P. So Y is the final amount. That's why here, if you look at this, so 19,500 equals A is the initial amount, which is 1,000. Oops. Alright, so if you look at this, B in this case, the question mentioned about doubling period, so you get double, therefore your B value is 2. Raised to the power of T minus T over P. T is the total time period, so your total time period is 90 minutes. And P is what you don't know, because P is the time it takes for the event to happen. In this case, for doubling to happen, so we don't know that, so therefore it is P. So now the only thing we don't know is P, so solve for P. And again, just like all the examples we've done so far, ideally if we can convert the numbers on the left and the right to have the same common base, then we can drop them and then solve for the unknown, but unfortunately we can. So what do? So we take the log on both sides. So before we do that, we want to simplify this first. Yes, there's nothing wrong if you do the log here, but it would be a little bit messy. So before we do that, let's divide both sides by 1,000 first. Divide this by 1,000. 1,000 is gone. Well, I'll just write down here. Divide this by 1,000. Divide this by 1,000. So take this. 19,500 divided by 1,000, you get 19.5. Right hand side, now we have 2 raised to the power of 90 over P. So now this is much nicer. So we can take the log on both sides now. So now take the log on both sides. Log of 19.5 on the left, right hand side, log of 2 raised to the power of 90 over P. And as expected, well, the left hand side there's nothing we can do, so leave that as is. And on the right hand side, as expected, you apply the power law and then move this exponent to the front, so you have 90 over P times log 2. Okay, then you want to multiply both sides by P so that the P is on the top instead of on the bottom, or you may say cross multiply. So that means P times log 19.5 equals to 90 log 2. Okay, and then of course now we can simply isolate P. So divide both sides by log 19.5. So on the right hand side, 90 times log 2 and then divide that by log 19.5. And I need more space. So now if you do that on your calculator, you would end up with a time of, well, in this case the question did not talk about rounding, so let's just round it to your nearest whole number. So that means the time is 21. 21 of what? Because this is a whole number, that's why I round my answer to the nearest whole number, minutes. So that means it would take 21 minutes to double the amount. Alright, so last question here. Let's quickly work on that. Have a look at the question first. Okay, so again, whoever created that has such a humor, so I'll put a happy face here. So you may not know anything about carbon dating, but those of you who were fortunate enough to admit for Chem 20, we briefly talk about carbon dating at the beginning of the semester when we were doing some Science 10 review. So anyway, so if you look at this here, it's just some sort of scientific process for archaeologists. So anyway, so if you look at this, we talk about the half-life. So that means we are going to use the same formula before, like last question, and then the last session on exponential function. So that means we should be aiming for, we should be looking at this formula again. Okay, so y equals to a times b raised to the power of t over p. Alright, so now if you look at the question, blah 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 blah, the bones found at a certain site have 12.3% of their carbon-14 left. If the half-life is 5,730 years, how old are the bones? So that means we are looking for the t, the total amount of time. Now the problem is, what is my initial amount? A, what's my final amount? If you look at the notes on this, the last topic for exponential function, then you'll find that we have two options. We either assume the initial amount to be 1, then we could have the final amount to be 0.123, or if you think the math is too hard, then this is what we can do. We can assume that the initial amount to be 100, and then the final amount would be 12.3% of that, so basically 12.3. So you don't have to do any math, okay? So 12.3. So look at the notes. This is what we're doing here. Assume the initial amount to be 100, and then 12.3% of that would be 12.3. Or if you assume the initial amount to be 1, then this amount would be 0.123. You'll end up with the same answer. Alright, so anyway, so now here for this question we'll talk about half-life. So that means my b value, the base would be 1/2, and then the total time is what we are looking for. So total time, and this 5,730 thing is the half-life, so the time for the process. So 5730. So that means whatever amount of time we figure out at the end for t, that would be in years. Okay, so I guess you all know that we should be taking the log on both sides, because there's no way we can have the same base. So, and again, before that, let's do some math. Let's simplify this first. Again, there's nothing wrong if you take the log on both sides, except that the numbers would be we will have a few extra numbers left. So let's just make it simple. Divide both sides by 100. Divide this side by 100. get just 1/2 raised to the power of t over 5,730. And then on the left hand side, if you take 12.3 and divide it by 100, then you get 0.123. For those of you who use 1 and 0.123, well, you save yourself an extra step. Anyway, so now we can take the log on both sides. So log of 0.123 equals to the log of 1/2 raised to the power of t over 5,730. Okay, and then there's nothing we can do to the left hand side, so leave that as log of 0.123. But then the right hand side, we can simplify it a little bit first, or move things around a little bit first, so we can apply the power law, move this to the front, so we have t over 5,730 times log of 1/2. And it's easy for the rest because we already did the hardest part. So get rid of the log 1/2, so divide both sides by log 1/2. So that means left hand side log 0.123 divided by log 1/2 is equal to, on the right hand side, the things left are t over 5,730. And the last thing to do is, of course, multiply both sides by 5,730 so that we have just t by itself. So that means t is log 0.123 over log of 1/2 and times this by, you might want to put it like this. Don't just put the 5,730 without the brackets, otherwise you confuse yourself. And of course, now the last thing you have to do is plug the numbers in. So after you plug the numbers in, you end up with a large number. And in this case, the question did not talk about the rounding. So here, the amount of time is in years without any decimal point. So we'll round our answer to the nearest year. So if you do so, we end up with 17,323 years. So